Back with another IDMP video, and today we're going to talk about data centers. Modern AI and HPC data centers generate massive volumes of operational data. Each compute node, GPU, cooling rack, and power system is constantly producing telemetry. Things like temperature, power draw, and pressure. IDMP allows us to collect, model, analyze, and visualize all of that operational data in one platform. One of the first ways IDMP provides this is a way to model the physical structure of the data center. Here we see the hierarchy of two different operations. You have the site of an IT management facility, the location, the cluster, the rack, and then things such as node and fabricator switches and scheduler jobs, all in one hierarchy. Separately, the cooling operations also has things such as cooling, which contains plant faults, plant 1 and plant 2, rack faults, rack 1 and rack 2 as well. This is extremely important because large data centers may have thousands of servers, hundreds of racks, and multiple cooling loops. This allows for end-to-end IT management. Also, IDMP and TDengine are more than capable of handling this data, as real customer use cases have 50 million data points coming in per second. Organizing this and the ability to store this is where the magic of IDMP happens. But what if we need to analyze each individual one of these elements? Well, we could do so with things such as dashboards. Here we've got a node dashboard that shows GPU utilization, CPU utilization, board power consumption, temperature info, and thermal tracking, which allows for end-to-end analysis on one node, the ability to templatize it so I could see it for all the other nodes, seeing real-time data come in. And using this data, operators understand how efficiently compute resources are being used, whether workloads are balanced, and if hardware is approaching thermal limits. Without a platform like IDMP, this information is often scattered across multiple monitoring tools. Thermal and cooling dashboards are also a great way to see one of the most critical problems with data centers, cooling. GPU clusters generate enormous amounts of heat. So, thermal throttling, hardware degradation, and unexpected outages in the cooling dashboard is what we're looking for. Things in the cooling racks, the coolant's temperature, and the temperature tracker. This allows operators to see in real time how heat is being removed from the compute nodes. This will allow you to detect problems like insufficient coolant flow, cooling imbalances, and failing pumps. Power and energy monitoring is another important analysis in a data center. IDMP allows operators to monitor both the cooling and power usage requirements. Here are some of the metrics we're tracking in here. We're tracking metrics such as node power consumption, total energy usage, and cooling system loads. With this information, operators can identify inefficiencies and optimize how the facility uses power. For AI data centers, even a small improvement of any of this information can save millions in operational cost. Now, going back to the node, what if I wanted to analyze a singular panel? Speaking about a singular panel can lead to differences in impact and understanding. And if I wanted to really understand one of the problems, one of the most brilliant features we have are panel insights. I can go into a panel and generate data insights on individual panels, CPU utilization, uh, analysis and hypothesis, business impact, and recommendations. Learning how to talk about your data is just as important as knowing everything about that data. Now, what if I wanted operational value for individual elements? Analysis is within IDMP are a great way to start. First, going into GPU utilization, here are the different ways you can monitor real-time data in IDMP. Here, I want to know if my GPU utilization goes above a certain amount and when it stops going above that amount. And I can generate events off of this. Because all data lives in the same platform, operators can identify different things in real time, which would otherwise be really hard to detect. Seeing things such as GPU utilization can get problems such as a runway job, overloading of compute resources, or thermal risk due to sustained generation. IDMP alerts these operators immediately once this happens in the form of events. Here are a couple events generated, and here are some of the events on an actual trend. I can even use IDMP to see differences between trends. So that's a couple GPU utilization events, but maybe I think a CPU utilization has some impact on it. I can add it to the trend. And then I can do things such as enable by start time, right? And then even normalize that data. Things you would need actual data analysts for no longer require that level of fidelity. Anyone is an expert data analyst within IDMP. I can correlate between data, I disable multiple swim lanes, so overlay metrics. One of the biggest advantages of IDMP is providing that unified monitoring, and you could do that across the platform. For IDMP, unified monitoring of compute systems, asset modeling, real-time visualizations, automated analysis and event detection, and rapid analysis event generation allows these capabilities to shine to improve reliability, optimize efficiency, and reduce operational risk. Thank you.